All right, welcome back. Now, in this particular session, we're going to start with what is referred to as recommendation systems. And I hope you have enjoyed the lesson so far. Recommendation system is one of the most used machine learning applications that we have in our societies today. In our world today, where data is booming and data is influxing everywhere, recommendation system is one of the ways that machine learning is being applied in most of the organizations and big firms. All right. From this session onwards, we're going to get an understanding of recommendation systems and the various recommendation system algorithms that we have in our world today. Okay, and we also go to the lab session and see practical implementation of recommendation systems. At the end of the day, we're also going to build our own movie recommendation system like Netflix. Okay, so we're going to see something like this where users can come and then search for whatever movie that they want. Okay, so as soon as they start typing, the recommendations will be there. They can just click on any of them, and once they do that, you see that it's searching over here, right? So this is a recommendation machine that we have built, right? Algorithm that we have built, which is running behind this app that we are going to see. Okay, now you see that the movie that I search is over there. Okay, you can see Star Trek Into Darkness. The movie is there, right? The actors and the actresses in the movie are also there, right? You can click on any of them and then you get an information about them. Okay, if you click on any of them, you get an information about these actors and actresses that we have. Okay, we're going to actually build this one right from the scratch. Okay, you can see the review of the movie is also there, the review, the status of the review, right? And when you come down here, you see that we have recommendation over here. Okay, we see we have a recommendations over here, right? I'm going to walk you through step by step as to how you're going to build your own application like this. Okay, if you click on any of these ones also, right, if you click on any of these ones, it's also going to search and then come up with that particular movie alongside the actors, actresses, and their reviews, right, as you can see over here. Okay, as you can see over here, so you can see we have the various actors in it, right, and you can click on any of them to get more information about them. Okay, more information about them, and then their reviews are there, recommendations are there. Okay, so we also going to do that on our own. We're going to build our own recommendation system like this. Okay, so this session is pretty much excited, and I'm very much excited for us to go through. I'm very much sure that you're gonna love this recommendation system session. So let's get started and dive deep into the recommendation systems. Let's get to understand the concept, the types, and the code and everything behind this recommendation system. All right, so recommendation systems have been with us so far. We've been doing this as humans. We've been recommending products and recommending services and a lot of different kinds of things as in our daily lives. Okay, we've been doing a lot of things, right? For instance, in our daily lives, we know that if you have bread and you add butter to it, it's gonna taste nice. Okay, we know that. So most of the time, when you buy bread, you want to add butter to it, and then it tastes nice. So as time goes on, people, the shop owners got to realize that most people who buy bread also buy butter. So sometimes you go to the, most of the time you go to the shop and then you see that where they have put bread, they have also put butter over there. Okay, to make it easier for the users to select and also for the people to also have more sales. Okay, because if the person is just coming to buy bread, you get the profit on only bread. But if you put butter alongside with bread, then you have the likelihood of selling bread alongside butter. Okay, so these things have been with us so far, right? They've been with us so far. So why is it now becoming a big deal? It's all coming from data, right? It's all coming from data. These days, the kind of data that we generate is beyond human comprehension. For every second, for every minute, for every hour, the kind of data that we generate, it's more than the previous 100 years that has passed. It's crazy, okay? And if you have a platform, if you have a big platform where you have a lot of products, it's going to be very difficult for you to be matching things like that, okay? To be matching things like that, and even personalizing the things, like particular customer liking a particular item and recommending something to a particular customer. That's gonna be very difficult. If your shop is very small, you can do these things manually. But if you have a big shop, right, it's going to be very, very difficult for you to do all those things, right? And especially if you have a digital shop, right, like Amazon or something like that, then I mean it will get out of your hand, right? It will get out of your hand. So that's when you need some kind of an automated system, right, to be automatically assigning things that complement each other, okay, something like that. Right, and you don't need to do those things manually, and that's when recommendation systems have become more practical or more vibrant in our societies. Okay, I think right now the most used part of machine learning is recommendation system, right, in the industry, right? And if you're very good at designing recommendation engines, trust me, the sky is just the beginning for you. Right, if you're very good at designing recommendation systems, building robust recommendation systems, the sky is just the beginning for you. All right. Now, there are several applications of recommendation systems that we can see in our recent societies. Right. One of the most robust places that you can find recommendation systems is Netflix. Okay, Netflix recommendation system is one of the top notch. I think so far. I've not seen any platform that uses recommendation systems like Netflix before. Like everything on Netflix is recommendation, right? Everything is about recommendation. There's nothing there that it's not running by recommendation, right? Everything on Netflix is recommendation. If I go to my Netflix, let me go and search for Netflix over here. If I go to my Netflix right now, okay, I'm just logging into my Netflix, and you will see what is there. Border. Right. Now you can see here, right? They have the movies over here, right? They have the movies over here, and then you can see that trending now recommendation, right? Trailer movies, US TV, blah blah, movies based on real life. Continue watching international. Now you see, because you watched Miss Bella, now to see that they are recommending some stuff over here. Recommendation. I mean, it's just everything here. You see that we have top 10 over here, recommendation, right? It's like Netflix is the home of research. If you want to research about recommendation systems, you cannot do it without Netflix. Okay, it's one of the most robust platforms that you can find recommendation systems. Okay, another platform that's recommendation system is more applicable is Amazon. Okay, Amazon is also having one of the most robust recommendation systems over there, right? There are a lot of things that they recommend over there. For instance, over here I search for this Lean Startup, right, and you can see that they are recommending other books that are closer or look similar to what I am searching, right? And that is purely recommendation. Previously, Amazon did not used to do this thing, but as soon as they started doing this, they saw the their profits hiking, like seriously. I've given you a link here where you can click on this link. Okay, click on this link. You go and see how Amazon recommendation systems work. In the same way, I've also given you a link here for Netflix recommendation system. I actually encourage you to click on this link and then go and see how these recommendation systems are, right? And you can even go to YouTube, research it by yourself, and you see how these recommendation systems are. They work and how awesome they are. Okay, it's quite incredible. Recommendation system is one of my favorite part of machine learning and deep learning in the whole. Okay, Facebook is also one of the giants when it comes to recommendation systems. These things are all over us, right? YouTube. You might have experienced these things a lot, right? On YouTube, if you click on something, right? If you click on, for instance, I click on TED Talks, you can see that all the recommendations here are TED Talks. Okay, so I'm not going to click on TED Talks and then they will bring me comedy movies. It doesn't make sense, right? So all these are just run by recommendation systems behind this YouTube over there, or behind these engines, and we're going to see how the various kinds of recommendations that they are actually using, right? For instance, Facebook is using a recommendation here, Amazon is using a recommendation here, Netflix is using a recommendation here, but they are not all the same. There are difference between them. Okay, there are different kinds of recommendation engines that are running behind these kind of applications. Okay, we're going to see the different types and also get to understand. Now, one of my favorite recommendation systems that I have so far come to love is Spotify. Okay, Spotify Discover Weekly, right? Some people create the playlist, and then if they find something that you like or something that looks like the playlist, they'll recommend that one for you. It's great, right? Because Spotify is having millions of songs over there. And if you want to sit down and then create these albums by yourself, or create these group of songs by yourself, that is going to be very, very, very difficult. Okay, and Spotify came up with this Discover Weekly thing, which is great. Okay, absolutely great. I've given you a link here, right? You can click on that and go and see how they did these kind of things. Okay, I urge you to just click on this link and then go and see how it is. It's awesome. It's awesome. It's great how they actually sit down and think through to come up with solutions like that, and it's going to help you in your own journey as well. All right, now this is what you're going to do in this particular tutorial. All right, applications of recommendation systems, as we have seen several of them, right? And it's all reverse, and I'm sure you're also a witness of recommendation systems in our society. We're also going to understand why recommendation systems are actually needed in the first place, and the techniques that are used in different recommendation systems, right? So as I pointed out earlier on, all these platforms are using recommendation systems, but they are using different kinds of recommendation systems, and some of them are even combining different kinds of recommendation systems to just perform one kind of an action. Okay, and we're going to see that over there. All right, and then we're going to see how we evaluate the recommendation systems. Okay, so after the recommendation systems have been built, we're going to see how it is being evaluated, and then we're going to have a hands-on with this recommendation system. So every recommendation system type that we're going to discuss, we're going to see how it is done in the lab session. Okay, before finally we go to our final projects and then build our own Netflix recommendation system like I showed you earlier on. Okay, build our own recommendation system like that. All right, so this is quite a great lesson for you, and if you're looking forward to master in recommendation systems, I highly encourage you to specialize in that. Okay, if you're much interested in that, it's great. It's a great career. It's a very, very great and lucrative career, and exciting one, of course. All right, so let's get started. All right, so we're going to start with why we even need recommendation systems in the first place. All right, so people can go to Amazon and buy anything that they want. So why do they still want to do recommendations? Why do they want to still spend so much money building recommendation systems, right? Or people can go to Netflix, choose the movie that they want and watch, but why do they still want to spend a lot of money in building recommendation systems? Okay, so let's get to understand it. Now, the first reason is to increase revenue. Okay, the first reason for companies jumping on recommendation systems is to increase their revenue. There's no motive behind that, right? If someone tells you something different, they're lying. The major reason here is to increase their revenue. Okay, because if, for instance, if you have a shop where you sell if you have a shop where you sell bread, okay, this is your shop. This is your shop. You sell bread over here. Okay, you sell bread over here, and then you sell bread for say $20. All right, you sell the bread for $20, and then out of this $20, let's say your profit is your profit is say $5. Okay, now if let's say you add butter to this shop, okay, let's say you know that people buy bread and also buy butter. Now this butter is let's say this is $10 over there. Okay, it's $10. So let's say out of this $10 to your profit is say $5. Okay, let's say your profit is say $5. Right, now how many dollars do you have over here? Right, now you have $10. Okay, you have $10, but earlier on your profit was just $5, right? Without the butter your profit was just $5, right? Now it's likely that in your shop most people buy bread. Okay, most people buy bread. However, you have also seen a couple of people who buy bread plus butter. Okay, they buy bread plus butter. Now, once you have discovered that in your shop, you can put them side by side. Okay, so if you put bread over there, right, you want to put butter right behind that. Okay, you want to put butter right behind that. So once they buy bread, right, their eyes also go to the butter. Okay, their eyes also goes to the butter. It's likely that they are going to buy both of them. Okay, it's likely that they are going to buy both of them instead of buying one of them, right? And that happens when your shop is very small, right? When your shop is very small, right? But if you have a big shop where you have about millions of products over there, it's difficult to actually fish out which items are my customers buying, and in addition to other items, right? What combination of items do my customers buy the most? It's going to be very, very difficult for you to figure those things out if you have a very big shop. Okay, you have a very big shop. I'm talking about digital shop in this regard. Okay, I'm talking about digital shop like say Amazon, right? Like Amazon.com or Amazon.in or Amazon.ca or whatever it is. Okay, if you have a digital shop like that, then it's going to be very difficult for you to figure out these things. Okay, that's why you need some sort of an automated system that will do these things for you, right? It will automate the process and then automatically match these kind of things, right? To just be behind your platform, seeing what people are buying and then continuously matching them. Okay, so if customer A, right, if customer A comes and then buy bread and buy butter, then if customer B comes, right, this automated system will now recommend these two to this customer, that okay, customer A bought these combinations, it's likely you will like it, and this one too can buy both of them. Okay, now in doing so, your profit is continuously going to increase. Okay, your profit is going to continuously increase. Now it seems like they are helping the customers, but ideally they are increasing their profit. Okay, that's the number one thing that they are trying to do, to increase their revenue. Okay, and of course they need to satisfy the customer before their revenue can increase. So as I gave example here, right, they are helping this customer to find the best product for himself or herself, right? That is adding butter to the bread that he wants to buy. Okay, but ideally they are doing that so that the customer will buy more items, and by buying more items they get to increase their profit. Okay, so the customer gets satisfaction, right, and then they get their revenue increase. Okay, the next one is personalization. Okay, so for instance, customer A, right, customer A here might have preferences different from customer B here. Okay, so if let's say this customer B comes and then instead of buying bread and butter, this customer B buys bread and jam. Okay, bread and jam. Okay, so now if this customer B comes back again to that is in day one. Okay, in day one, that's what customer B did, right? So if this customer B comes again to the platform and buys bread, automatically this one will recommend jam instead of recommending butter. Okay, that is personalization. But if customer A comes, sorry, this system will recommend butter instead of jam. Okay, if this customer A comes to buy bread again, the system will recommend butter instead of jam. Okay, so that is personalization, right? Looking at the individual preferences and recommending things that they personally like. Okay, now the next one is discovery, right? Discovery, as I said, if your shop is very big, it's actually going to be difficult for you, the shop owner, to match things like that, and also for the people to discover the things that you have over there, right? If you have experience, I'm sure if you have been doing online shopping, you will realize that sometimes it becomes very, very difficult, right? If you're looking for that particular shoe, okay, if you're looking for some shoe that will fit you well, or some kind of a dress, right, you can spend a whole lot of time going through Amazon or going through eBay or any other platform, right, trying to find the best dress or the best shoe or suit or something for you, right? It's very difficult. You can spend a day or two just going through these things, right? Now with the recommendations, right, with the recommendation systems, they can make these things easier for you, right, by just helping you discover things that the platform is having, right? So if for instance you want shoes and you type in the keyword shoes, right, they're gonna come up with the best shoes that most people are buying on the platform for you, right, and even give you some suggestions, right, and then say that okay, you may also like these things, right? You see these things, this statement over there, you may also like, right, something like that, and you see list of other products over there. You'll be seeing list of other products over there. So instead of you going through the platform and find all the products like what you are looking for, right, then this kind of suggestions will help you discover the other products over there easily. Okay, so that is another thing. The last one over here is report and analytics. All right, so now if the platform owner, right, the shop owner or the platform owner wants to know what is going on the platform, right, is the activities that the customers are performing, right, on the platform that will give the company insight, and then for them to know what to do, right? For instance, if most people buy bread and butter, they know that we are, in our shop, we are supposed to put more bread and butter over there. That's kind of an insight or analytics that they're having. Okay, if most people are buying some kind of a product, you need to know how to keep your inventory of that product, so that you not run short of that product that is giving you more profit. Okay, where is our most profit coming from? You need to know that, so that that product will be your top-notch product on your platform. Okay, and how to even place these items on your platform are all going to come from the reports and analytics that you're going to get from these kind of recommendations that is on the platform. All right, so these are some of the reasons why we need recommendation systems in our system, right? In our platforms and in our companies. Okay. All right. So I hope now you have an understanding of why we need recommendation systems and why so many companies are jumping on recommendation systems. So you will not see recommendation systems on, say Netflix, and you think they are trying to make your work easier. Of course, they are making your work easier, but the ultimate goal is to increase their profit. Okay, for you to spend much time on Netflix watching a lot of movies, so that next month you keep on watching, right? Especially for those who like series movies, right? They try as much as possible to recommend you the best series, because they know once you watch one series movies, it's gonna take you about 2-3 months, and each month you're going to subscribe, right, and increase their profit over there. All right, for them, although you're watching your movie, having your own satisfaction in your own way, but you're increasing their profit. Okay, so that is how it works. And in the same way, on Amazon, they have a lot of recommendation systems they want to use to increase their profit over there, right? Now, what we're going to do next is to understand the various types of recommendation systems that we have in our industry, right? And then we will take them one by one and then discuss them. All right. So these are the various recommendation systems that we have so far in the industry, right? We have what is called popularity-based recommendation systems. We have classification based recommendation systems. We have content-based recommendation systems. We have collaborative filtering. We have hybrid approaches over there. Okay, so we're gonna take them one by one and then get to understand what these recommendation systems are, right, and how it is being implemented. All right, so let's get started and then get to understand these recommendation systems in details. All right. Okay, so we're gonna start with popularity-based recommendation systems. Okay, and I think for most of the companies, popularity-based recommendation systems are all over their platforms like Netflix or Amazon or any other platform. You can find popularity-based recommendation systems, especially in newspaper platforms like New York Times and The Guardian and the Economic Times and all those platforms. You will see popularity-based recommendation systems a lot over there. Okay, so this is a screenshot that I got from my own Netflix over here, where you can see that we have they are recommending the top 10 movies over there, right? I'm actually going to go to my Netflix and then show you these things. Okay, so let me go to Netflix over here, right? Now if you go to Netflix, if you go all the way down, right, let's go all the way down. Here you can see that we have top 10 in India, right? Because now I'm in India. The time that I took this in, I was in the US, so that's why you see top 10 in the US. But here you can see that top 10 movies in India. Okay, top 10 in India today. That is what is trending today. That is what most people are watching right now in India. So you can see that if you go all the way here, right, 10 movies are there, right? The last one is over there. Okay, this is based on popularity. What is trending, what is going on right now is what they are recommending, right? Okay, so they are basing on the popular views and then they are recommending these kind of movies to you. Okay, they are basing on what most people are watching and then recommending them to you. All right, that is popularity based recommendation system. All right, if I go to Amazon right now, right, let me go to amazon.in. right now, if I go to Amazon right now, you can see that if you come here right now, you see that we have today's deals, right? Today's deals, that is popularity based over there. Okay, that's popularity based over there. They are based on what people normally search, right? The items that people actually search, and then they'll create it and then call it today's deals for you. Okay, because they know they are popular over there and most people are gonna order. Okay, if you come here, you can see that we have created protective supply products. Now you see that because of the COVID situation, right? Because of the COVID situation, you can see that they are recommending some nose masks and things that are related to COVID. That is popularity. Things that are popular right now. That is what people are really searching, right? Because of the COVID situation, most people are searching for products that are related to COVID. That is popularity. Okay, that's popularity based sanitizers and nose masks and things like that. Okay, that is what is popular. Okay, you can see what they are doing over here, right? So that is popularity based, right? And I think the best one that you can find is the Netflix over here, right? Top 10, right? Spotify is also having its own popularity base over there, but I think you have the idea by now. Okay, so based on what people are watching the most, right, they base on that and then they do the recommendation for you. All right, so that is popularity based recommendation systems. Okay, so I hope you have the idea by now. All right, so let's go back over here. Now, as I said, you can also find the same thing on Amazon, right? Just like I showed you right now. All right, so these things are, I mean, based on popularity based. They based on what people are searching right now and then recommend it to you. So I took this image, I mean, as I was about to record this video. That's why you see similar thing when I go to Amazon. You see it over there like that. All right, so I mean, that is popularity based recommendation systems. Now let's see how they actually do these kind of popularity based recommendation systems. So as I said, they actually go with the trend. Okay, what is trending right now is what they base on to do these kind of recommendation systems. Okay, so it works based on the trend, right? And before they get the trend, they base on maybe what most people are rating high, okay, and what people are actually watching the most, right? Something like that, right? The view count and something like that, right? They base on something like that, and then they do the recommendation. So this kind of recommendation is not dependent on customer A or customer B or whatever. It depends on the entire population, right? What the entire population are watching, right? The most is what they are recommending, or what they are rating is. I mean, which movies are having the highest rating is what they are actually recommending over there. All right, so that is popularity based recommendation system, right? In the lab session, we're going to see how this popularity based recommendation system is actually implemented. All right, so let's get to the lab session. All right, welcome back. Now in this particular session, we're going to consider the popularity based recommendation system, right? You're going to have a hands-on of how these popularity based recommendation systems are built. All right, so in the previous video, we got an idea of what popularity-based recommendation systems are, and in this particular tutorial, we're going to have a hands-on on that. Okay, so let's get started over here. I'm going to use two different data sets over here, right? So one is called movies.csv and the other one is called ratings.csv, which I have loaded at a resource session for you. Okay, so you can download them and then you can work alongside. I'm using Google Colab over here if you want to work alongside it, but you can also use Jupyter Notebook or Jupyter Lab to work alongside. All right, okay, so let me load these data sets for you to see what is inside here that we're going to use. Okay, so I'm going to use these libraries, which is I'm not going to need this one. I'm just going to import NumPy and Pandas over here. All right, so let me run that. Great. Then the next thing that I'm going to do is to read my data set. Okay, so I'm using pd.read_, and I'm reading the movies.csv. Okay, then I'm storing its movies names. Then I'm going to print it out for you to see. All right, great. So this is what we have in the movies.csv. So this is a movies data that we are going to use for this particular exercise. Okay, all right, so we have the movie ID, then we have the title, and then the genres over here. Okay, so the movie ID is just nothing but like the way Pandas has given us an ID. Okay, so each of the movies are having the ID, which in this case we are not going to use for any of our analysis over here, right? And then we have the title and then the genre. Let me also load the ratings also for you to see. Okay, so here I'm doing pd.read_csv, and I have put in my ratings.csv over here, right? And I'm storing it in ratings_csv. So let me read that for you to see. Okay, great. So in the ratings, we have the user ID, the movie ID, rating, and then timestamp. Okay, that is the time that they were giving the ratings, right? And the movie ID and user ID, which we are not going to use in this case. So what is important here is the ratings. Okay, so now we want to put together the ratings and also the the data that we have on the movies, right? So the title and then the ratings are what we want to combine together. So let's see how we're going to do that. So we're going to use the merge function over here, right? Pandas merge function, and I'm putting in the ratings data and the movies data, right? And since all of them are having movies ID, right? Movie ID is here, movie ID is also here, so I can merge both of the data sets on that movie ID, which they all have in common. Okay, so that's what I'm doing over here. All right, so now if I print the head of it for you to see, right? So this is what we have. Okay, this is what we have. So now you can see that for the ratings, right, because I brought the ratings first, the ratings data is going to come first. User ID, movie ID, rating, and timestamp. So you can see here user ID, movie ID, rating, and timestamp. Then after that, the movie names are going to come. That is this movie, right, which starts with the movie ID, title, and genres. Right, but since we match them on movie ID, only one movie ID is gonna come. So this one is gonna start with title and genres over there. Okay. Now once that is done, we need to define a criteria that we're going to use for this popularity-based recommendation system. Okay. Now the criteria that we're going to use is that we're going to find the movies that are having the highest ratings, right, and also the movies that are having the highest number of views, and then based on that we can make the recommendation. For instance, if you go to Netflix, right, so based on that, this top 10 movies that you see over here is based on the highest ratings and the number of views. Okay, is what they are basing on to give you this kind of recommendations. So that's what I'm going to base on to do this one. Okay, so what I'm going to do is that for each of the movies that we have, okay, for each of the movies that we have, one person might rate it 2, one person might rate it 3, one person might rate it 5, and so on and so forth. So on average, what is the rating of that particular movie? If I pick one movie, on average, what is the rating that that movie is having? So that's what I want to calculate over here, right? So in my movie data, which is what I've just formed over here, which is a merge of the ratings and the movies, right? When I go inside there, I'm going to do group by, and I'm grouping it by the title, okay, and then I'm going to find the mean of the ratings, okay, specifically for the ratings, right? Then I'm printing the first 5 for you to see. So let me run that. Okay, so for each of the movies, you can see that they have ratings over there. Okay, for each of the movies, you can see that we have ratings for them. So great performances, Cats 1998. You see, this is the rating for it, right? And then Hellboy, right, the Seas of Creation, this is the rating over there. The Arizona Skies, blah blah blah, this is the ratings over there. Okay, now what I'm going to do is that I'm going to sort them. All right, I'm going to sort them according to those movies that are having the highest ratings. Okay, that's what I'm going to do over here. So I'm just copying the same code, right? Movies.group by the title. Okay, movies.group by the title, ratings.mean. Then after that, I'm adding sort values, right? And I'm setting ascending equals false, so that it will send it from the highest to the smallest instead of smallest to the highest. Okay, so let me run that for you to see. Okay, now you can see over here, right, that the movies that are having 5-star ratings are the ones that are coming first. Okay, that is the first 10, right? If I put that is the first 5. Okay, if I put 10 over here, I'm gonna have the first 10. Right, now you can see these are the movies. If I do maybe first 30 over here, okay, you see that in ascending order, right? These are the movies that are having these are the first 30 movies with the highest ratings, right? Ratings 5. Let me see, let me go to 50 and see if I'll have the ratings with 4 also. Okay, which means those with 5 ratings are a lot over there, right? They are a lot over there. But one thing that I want to also know is the count, right? Maybe one person who watched this movie and rated 5, okay, and maybe this one is about maybe 20 people who watched it and rated at 5. So in that case, I'll give more importance to the 20 people who have watched this the same movie and rated it higher than just one person watching it and giving it a 5-star. Okay, if I want to make the recommendation, I want to base on the popular ratings. Okay, so if 5 or 20 people have watched a movie and rated it 5, I consider that movie as popular than a movie that one person has watched and rated it 5. Okay, so I want to also check the count as well. So let me go down here, and then here I'm going to check the count. So just the same thing, but in this case, instead of mean, right? Instead of mean, I'm using count, right? Earlier on, I was using mean, right? If you see over here, right, I'm using mean over here, right? But now I'm going to use count over there, right? I'm using count over there. So let me run that one. Great. So you can see that now I have the count, right? The count over there as well. Right, so what I'm going to do is that I'm going to add both of them together, the ratings and the count. Okay, I'm going to add both of them together on the same table, right? So if we go into our data, right, I'm only going to select the rating and then the title. That's the only thing that we're going to base on, right? The movie title and their ratings, right? And also, then I'll add the title count as well, right? So that's what I'm going to do. So if I do this one, right, I'm gonna get the movies, right, the title of the movies and their ratings. Okay, so now let me do this thing again, right? I'm going to now store, right, if I do the calculations over here, right, like I was calculating the mean, right? This one, and I did not store it in anything, so I'm going to store it in a variable called ratings mean count. Okay, that's what I'm going to do. So let me do that one and let you see. And I'm also converting it into a data frame over there, right? Unlike here where I just this one was not in a data frame, okay, but I'm converting it in the form of a table, right, in a tabular form. That's why here I'm using pd.dataframe over there. All right, so now once I do that, I'm grouping it by the title, right? So that's why instead of having an index like this, right, I don't want the index like this. I want the title to rather be the index, so that I'll have the title and their rating and their rating count. Okay, so now I have the title and their rating, so I'm going to do this one over here, so that I'll also have the rating count. Okay, inside this ratings mean count, I'm going to add the rating count as well. Okay, and this how I'm counting it. So instead of mean, I'm using count. Okay, so that I'll get the rating count and then add it to that table. All right, so let me run that one for you to see. Great. So if I print the head of that, right, if I print the head of that again, right, now you see that I have the title, the ratings, and then the ratings count. So for great performances cut 1998, 2 people rated it, right, and out of the 2, on average they rate it as 1.75. okay, if you see this one here, just 3 people rated it, and on average they rated 3.8 something, right? If you see around midnight, right, 2 people rated it, and on average they rated at 2.25, right? On Zenith, the Arizona skies, right, 1 person rated it 0.5, right? Now what I'm going to do is that I'm going to find a way to cut off this many decimals that is behind. If it is 1.7, let it be 1.7 ratings. If it's 2.0, let it be 2.0 ratings. If it is 0.5, let it be that. Okay, if it's 2.2, let it be like that. So that's what I'm going to do. Okay, so I'm just gonna add rounding to the rating column. So in my ratings underscore mean count, which is this, what I have over here, right, this table, right, I'm just gonna select the rating, and I'm adding the round function over there, right, and I'm rounding it to 1 decimal place. So after the decimal point, I'm supposed to just see one digit over there. Okay, and that is gonna be our new rating over there. So let's run this one and see. Great. So now let me show you what we have right inside here. Okay, great. So now you can see that instead of 1.75, we see that we have 1.8 approximately, right? Because this is 5. So 5, since it is 5, it's going to add 1 to this one to make it 1.8. It is less. If it is less than 5, then it will ignore it. Okay, for instance, we have 3.83. This 3 is not up to 5, so it's going to be just 3.8. If we go here, you see that we have 3.8 like that, and so on and so forth. So what I'm going to do now is that I'm going to now bring our criteria that we set earlier on. Okay, so our criteria, if we go all the way up here, we said that we want movies with the highest rating and also number of views. Okay, so that's what I'm going to do over there, right? Because now the count is here, but you can see that some of them are 2, right, some of them are 3, and so on and so forth. And then the ratings, these ones are not sorted, so I'm just gonna sort them over here. So what I'm going to do is that if I go into my ratings, right? If I go into my ratings underscore mean, I'm going to select the ratings, okay, and then I'm going to select only the ratings that are higher than 3, okay. So if the ratings are less than 3, it's not a popular one, okay. You can maybe increase this criteria to maybe 4, right, so that you have only those movies that are having ratings 4 and above, okay. And not only that, I want also the count of the ratings, that is those who have rated it to be more than 100, okay. So if more than 100 people have rated a particular movie more than 3 stars, then I know that that particular movie is popular, okay. So that's what I'm doing over here. Let me run that for you to see. Okay, great. So you can see that these are the movies that are having ratings greater than 3, right? And then you can see that the number of ratings are also more than 100 over there. Okay, they are more than 100 over here, right? So that's basically what I want. That's the criteria that I have set. All right, now what I'm going to do is that you can see that over here they are not actually sorted, so I'm just gonna sort it by the rating, okay, so that I'll have those that are having the highest ratings to come first, okay. So let me do that. Okay, great. So you can see that now I have 4.5 ratings, 4.5 ratings, 4.5 ratings. The 5 ratings are not coming here because the account, the number of people who have rated movies 5-star are not up to 200. Okay, so unless maybe you want to reduce your criteria over here, right, you want to reduce this criteria over here so that you have that one, right. But you can see over here for those that are having their ratings greater than 3 and also their count is more than 100, these are the movies that we have, okay. So if Netflix is to do the recommendation, right, you will see Godfather there, you will see Shawshank Redemption over there, right, you see Usual Suspect over there. These kind of movies are going to categorize as the top 10, okay. So these top 10 that you go to Netflix and you see, this is how they do it. Okay, this is how they do it based on the popularity of the ratings and also the ratings count. Okay, so I hope now you have an idea of how popularity based recommendations are being built. Okay, so this is basically the idea behind popularity based recommendation system. All right, now in the next tutorial we're also going to consider another kind of recommendation system and also come to the lab and see how that is also built. Okay, all right, so don't forget to give a good rating and a good review to the course, right, and that's a good motivation for me as well. Okay, as I keep providing you with good content, you can in return give a good rating and a good review to the course, okay, and also leave all your comments at the Q&A session, right. I'll be there to answer all your questions over there. All right, so see you in the next tutorial. Have a nice day. All right, welcome back. In this particular tutorial we're also going to see what is called content-based filtering or content-based recommender systems. Okay, so in the previous tutorial we considered the popularity-based recommender system, right? So in this particular tutorial we're going to consider the content-based filtering or content-based recommender system. Okay, all right, so let's get understanding of what content-based filtering is, and then we go to the lab session to see how we can implement this content-based filtering or recommender system. Okay, so in content-based filtering, right, as you can guess over here, right, it's content-based, meaning that we base on the content to make whatever recommendation that we're going to recommend. Okay, so for instance, a user has viewed a particular product or a user has read a particular article, okay, on your platform, then based on that particular article that the user has read, you look for similar articles and then you recommend that similar article to the user. Okay, so they have already performed some tasks, you base on that activity that they have performed and then you recommend a new the similar product or the similar article to them. Okay, and that is content based. Okay, this one is based on the content, right, the content that looks like what the user has already consumed. You base on that to make the recommendation. So that's why it's called content based. Okay, what content the user is searching is what you base on to make the recommendation. All right, now this one can be seen in several in places, right? So on Amazon, depending on the product that you're gonna search, they base on that to recommend similar products to you. Okay, all right, so if I go to my Amazon, right, if I go to my Amazon here and then I search for say if I search for say chocolate, right, now based on what I have searched, right, let me just click on this one. Right now, if I click on this chocolate, right, and then I go down here, you see that they are recommending like products related to this. Okay, so they are based on the content that I have searched, and they are recommending similar products, right? So I will not search for, say, I will not search for chocolate and then they will be recommending baby clothes to me. Okay, they will recommend similar products, right, which are chocolates. Okay, whatever they are going to recommend are going to be similar products which are chocolates. Right, so that is content-based recommendation system. Right, if you go to news portal like, say, New York Times, right, if you go to New York Times, for instance, right, and then let me go to home. Okay, now over here, depending on the content that I will search, right, they are going to recommend similar content to me. Okay, so for instance, if I search for, or if I go into, say, health, okay, if I go to health, and then inside health there are several stories over here, right? So let's say that I just select one of them, right? So let me select this one and see. All right, now once I click on a health related article, right, they are going to recommend similar articles that are related to health to me. Okay, if I scroll all the way down here, right, now here you can see that whatever is here is related to health. Okay, whatever news that is over here is related to health. Okay, they're all going to give me health related articles. All right, so based on what you have searched, they look at they based on what you have searched before, and then they recommend items that are closer to what you have searched before to you. Okay, so there are a couple of things that I want you to understand over here when it comes to content-based filtering. Okay, so as I mentioned earlier on, content-based filtering actually uses the closer items to each other, right? They look at items that are closer to each other, that is items that are similar to each other, and then they recommend it to you. Okay, so if user A has seen some article or has seen some products and rated that article or rated that product good, right, then when the user come again, they are going to recommend that product to the user. Okay, they are going to recommend that product to the user, right? Also, if a user search for product A, right, if a user search for a particular product A, right, then similar items that look like product A are going to be suggested to user. Okay, similar items that look like product A are going to be suggested to the user. All right. And in this case, you don't really need the data of other customers. Okay, you don't really need the data of other customers to do this one. You can base on user A, right, user A's behavior or user A's past records, and then you base on that to make the recommendation. All right, and in this case, we use technique called cosine similarity. Okay, we use technique called cosine similarity to do that. I'm going to explain that to you in a moment. All right, and whilst you're doing this, there's also a caveat in this recommendation, right? The content-based recommendation system, there's a caveat over there, right? So imagine I go to Amazon, then I buy, say, blue jeans. Okay, I buy, say, blue jeans over there. Right now, if I buy blue jeans and I buy blue jeans today, then tomorrow I go to, so today I went to Amazon, I bought these blue jeans. Now tomorrow if I come, right, to Amazon again, right, what Amazon is going to do is that they're going to recommend blue jeans to me. Okay, that because that is the content that I have searched before, so they're going to recommend blue jeans to me. Meanwhile, if I buy the blue jeans, right, I don't really need another blue jeans, right? I don't need blue jeans again, right? If I come the next day, right, if I come again next day after tomorrow, they're still going to recommend that blue jeans to me. Okay, they are going to recommend blue jeans to me. And the recommendation, according to this content-based recommendation, is based on the content that I have consumed before and recommending it to me. Okay, if it is news portal, right, if it is news portal like NY, right, that's New York Times, right, NYT, right, that is okay, because if they recommend say health article to me today, right, and I come and they are recommending health article to me tomorrow, that is fine, because the articles will vary. Okay, the articles will vary, and I want to read the different contents of the article. But when it comes to, say, buying blue jeans, right, although we can have different types of blue jeans, but if I buy one blue jeans, maybe I will want another black jean or something like that, right? And if I come the third day, I wouldn't want to even see blue jeans again, right? Maybe I want to buy top or something like that. But if you're continuously showing me blue jeans, I mean, I cannot wear blue jeans all the rest of my life. Okay, so that is one caveat over there, right? Although sometimes they can show you and you can still be interested in the new blue jeans that they are showing you, right? But it's a caveat, and it's, I mean, somehow good for them, right? If you end up buying it again, it's good for them. But if they continuously bother you with blue jeans, you might end up not coming there again, right? Okay, so that is some of the caveats that you can find when it comes to content-based recommendation system. Okay, now let me explain this cosine similarity to you, so that you get to understand what that means. All right, so for the cosine similarity, this is how it works. Now let me even start with Euclidean distance. So cosine similarity is nothing but a distance measure. Okay, it's a distance measure. If you remember, in our previous machine learning class, we talked about the various distance measures. Okay, and we mentioned cosine similarity over there. Right now, one of the distance measures that we talked about was Euclidean distance. Okay, we talked about Euclidean distance. Okay, so if you take that Euclidean distance, for instance, right, and you said that you want to remember that we are saying that we in content base we recommend items that are closer to each other, okay, or that look alike. Okay, so if depending on how similar the items are, we're going to have some kind of a number associated to them, so that we'll be able to measure how items are closer to each other. Okay, now for Euclidean distance, let's say that we have this kind of data points, right? Let's say this is our data point. Okay, let's say we have two rows over there, right? We have row 1, and then we have row 2. Okay, so inside here we have some data points in there, right? So let's say in row 1 we have data point like 2, 1, 3, 4, something like that. Row 2, let's say we have data points like, say, 3, 4, 0, 2, something like that. Okay, now what Euclidean distance is saying is that if you want to calculate the distance between row 1 and row 2, then you need to do something like this. Okay, x2 minus x1 squared plus plus y2 minus y1 squared. Okay, and if you have more points over there, right, then maybe you can have z1 minus z2, right, squared, and so on and so forth. Okay, and so on and so forth. So after that you find the root of that. All right, so that is for Euclidean distance. So in this particular case, if we take the example that we have, right, we're going to have something like, say, if we represent this one with x1 and then this one with x2. Okay, so that's gonna be something like this. Let me do it like that. So that's gonna be something like this: 3 minus 2 squared, okay, plus 4 minus 1 squared, okay, plus 0 minus 3 squared, 0 minus 3 squared, okay, plus 2 minus 4 squared, something like this. Okay, then we find the root of all that. Now if we do this one, we're going to have something like 3 minus 2 squared, you're going to have 1, squared is still 1, right, plus 4 minus 1 is going to give you 3, squared is going to give you 9, plus 0 minus 3 is going to give you minus 3, squared is going to give you 9, plus 2 minus 4 is going to give you 2, squared is going to give you 4. Okay, 4. All right, so this is what we have. Then we find the root of that. So this can give you something like 18, 19 plus this one 23. So root 23. Okay, which can end up to something like 4.7 something, 79, something like that. Okay, something like that. Now if we do Euclidean distance and we get something like this, right, we get something like 4 point something like that. Now what is this actually telling us? Okay, What is this actually telling us? This one is telling us the distance between row 1 and row 2. Okay, but this one does not give us the similarity between the two rows. Okay, it's giving us the distance between the two rows, but not the similarity between the two rows. But in this case, what we want is the similarity. Okay, because we want, if a user watch one or read one article, we want to see another article which is similar to this article that the user has read, right? So that we can base on that and make the recommendation. Okay, but this one will give us the distance but not the similarity. Okay, and that's when we have the cosine similarity. All right, that's when the cosine similarity will come in. So let me get rid of this one, and then I'll show you how the cosine similarity works. Okay, so we're going to consider the cosine similarity. Okay, so for the cosine similarity, we say that we calculate, it gives us the similarity, right, between the two items. Okay, so the cosine similarity is actually simple, right? So what it says is that it's a dot product of the two. So let me bring the data that we're using, right? Let me redo it over here. Okay, so let's say this is what we have. All right, I'm just gonna call it X and then Y. Okay, instead of say row 1 and row 2, I'm just gonna call it X and Y, right? And then I'm just going to divide these things. So let's say we have 1 here, like that. And then let's say we have something like maybe 2, 4, 12, something like that. Okay, now what cosine similarity is saying, that it's a dot product between X and then Y. Okay, so you're gonna have X dot, let me bring it up, X dot Y divided by the absolute value of X, right? So like that, dot the absolute value of Y, like that. All right, okay, that is let me rewrite this thing so that you know what I wrote. Okay, X with that pipe sign over there, dot Y with that pipe sign over there. Okay, that is the formula for the cosine similarity. Let me expand this one further so that you will get to understand it. Okay, so this one is nothing but this xy divided by summation of all x, okay, from say I squared, okay, multiplied by the summation of all y squared. Okay, so y I squared, like that. So in the the example over here, we're going to have something like that is for the upper part, for the numerator, like this. So I'm going to do it for the numerator and the denominator. So for the numerator, you're going to have something like this. This multiplied by that, this multiplied by that, this multiplied by that. Okay, and then you find the summation of that. So it's going to be 2 times 1, like that, plus then 4 times 5, like that, plus your 12 times 2. Okay, that's going to be the numerator. And then for the denominator, it's going to be s squared, right? It's the summation of all the s squares, which means that we're going to have 2 squared plus 4 squared plus 12 squared, right? So 2 squared plus 4 squared plus 12 squared. Okay, this one is going to be 1. Then we multiply it by the y, so the y is going to be 1 squared plus 5 squared plus 2 squared. Okay, 1 squared plus 5 squared plus 2 squared. Okay, there's actually a root over there. Okay, we need to find the root of that. So once we are done, we find the root of this, right? We find the root of that, right? Okay, so here we can have here we have something like 4, right? That is 2 square, right? Plus 16, and 12 square is something like 144. So if you add this, then we're gonna have 4 plus 16, which is 20, and then plus, so we're gonna have 144 and then 20 over there. Okay, which is gonna give us 461. Okay, 164. Okay, 164 over there. So let me bring whatever that we're gonna do up here. Okay, so we're gonna have the upper one is going to be, let me finish simplifying the upper one. The upper one is going to give you 2 over here, and then 20 and 24. Okay, which means that we're going to have and this is 20, this is 24, okay, which means we're going to have 22 plus 24, okay, which is 46, okay. So we're going to have 46 on the numerator, and the denominator we're going to have let me do this, root of 164, right, okay, multiply by root of, so this one will give us 1 squared, it's going to give us 1, 5 squared is going to give us 25, and 2 squared is going to give us 4, okay. So it's more like 25 plus 5, which is 30, okay, something like this. So let's see how this calculation goes. So this one is going to come down to something like 0.655, something like that. You can just do the simplification and then you will see, right, root 164 multiplied by root 30, right, and then 46 divided by that. You can do it and you'll see you're going to go somewhere like 0.655, right, something like that. Okay. All right, now the cosine similarity value ranges from 0 to 1, okay, ranges from 0 to 1, and if the number that you get is closer to 0, it means that the similarity between them is very less, right, which means the items are not that closer, right. For instance, if someone search say chocolate, and then you're going to show something like butter, okay, they are all things that you can eat, but they are not that similar, okay, they are not that similar. So if in that case, if we calculate the cosine similarity between say chocolate and butter, you have something like maybe 0.01, something like very less, okay. However, if we check something like maybe chocolate and another brand of chocolate, okay, one brand of chocolate to another brand of chocolate, you can have something like 0.5 and above, okay, so 5 and above, maybe 0.7 or 0.8 or something like that, okay. In that case, they have stronger alike or stronger relationship, okay. They are close, very much closer to each other. So if you see the value that we have over here, which is 0.655, right, which is above 0.5, okay. So in this case, we say that the similarity between them is quite strong, okay. The similarity between x and y, so if x is one brand of chocolate and y is another brand of chocolate, then we will surely recommend y for anyone who will search for x, okay. That is how cosine similarity works. All right. So for each of the items that you see on Amazon, they calculate the cosine similarity. If you search for any item, they will calculate the cosine similarity of that and then recommend the similar items to them, okay. So it's not like you can search for say chocolate and they will be recommending shoes, okay. Shoe is not the cosine similarity between chocolate and shoes will be very less, okay. It will be very less. All right, so that's how cosine similarity works. All right, I'm going to show you how you can also do it in Python, or how you can use Python to calculate the cosine similarity, right, at the lab session. All right, so let me show you how you can use Python to calculate the cosine similarity. Okay, so previously we have seen how to do it by hand, right? So we calculated the cosine similarity using our hand, and we got to understand how it is done. But you can also do it in Python. Okay, so from here, what I'm doing here is that I'm importing everything in math. Right, in math, there's a lot of things over there, some statistical formulas that you can use. Right, that's what I'm using, and then I'm going to create a function over here, right, which I'm just going to name it as square rooted x. Okay, so I'm creating two functions over here, square rooted, right, and then cosine similarity. Okay, so inside the cosine similarity, let me explain that before I come to the square rooted. All right, now inside that, right, we say that if you have the items, right, previously we said that if you have say the items, so we use a table like this, right, and then we represent here by x and then here by y, and then we got some values in there, right? So let's say 1 0 5, something like that, and then maybe 4 7 3, something like that, and then we measured the cosine similarity, and then we were saying that the cosine similarity is nothing but the dot product, right, the dot product of the two. So we ended up doing something like this, multiply by that. Okay, we ended up doing something like that. So when we expanded it, we got to realize that up here is nothing but the dot product of x and y. So it's gonna be 1 multiplied by 4, right, something like that we got, and then 0 plus 0 multiplied by let me do it here. Let me cancel it here. So plus 0 multiplied by 7, okay, plus 5 multiplied by 3. That is going to give us this one. Okay, so we did something like that. That's what I'm doing over here, right? So a multiplied by b is nothing but x multiplied by y, like what you're seeing over there, right? For every a and then for every b, okay, in x and y. That's what I'm doing. So for every a and every b, do that multiplication for me. Okay, that's what I'm doing over here. That's going to give me the numerator. Okay, and then for the denominator, it's going to be the root. Okay, when we expanded these things, we realized that it's equal to the summation of the xi, right, root of that multiplied by y's, that is the summation of all the yi's. Okay, and then square of that. Okay, we find the square of that one. That's gonna be this one over here. So that's what I'm doing. I'm using this square rooted, which is another function over here. So square rooted is going to take each one of the items. So for instance, if we pick 1 here, we want to do 1 squared. Okay, so that's what you're seeing over here. Each one of the item multiplied by itself. Okay, because if I want to take, if 4 square is the same thing as 4 times 4. Okay, so if 4 represents a, then it's the same thing as a times a. Okay, so that's what I'm doing over here, right? For each of the a's in x. Okay, for each of the a's in x. So that's what you can see, a times a over there. If it's the y values is the same thing, if it's the x values, I just do it like that. Okay, and then finally I find the sum of that. Okay, and then I find the root of that finally. Okay, that's what I'm doing it. And here I'm rounding it to just 3 decimal points after the decimals. Okay, so that's the function that I'm going to use over here, right? Multiply by the square root. So the square rooted of x, okay, the square rooted of x multiplied by the square rooted of y. That's what you're seeing here. Square rooted of x multiplied by the square rooted of y. And then after finally I put them in the formula. Okay, so the numerator divided by the denominator over here. Okay, that's what I'm doing. So let's run this one and see. Great. So now if I have let me bring this one. If I have this one over here, right, let's say this is my x, this is my y. Okay, so you can think of it as a row and column like this. Okay, where we have x and then we have 1 2 3 4 items in there. So 1 2 and then 3 4. Okay, so the first one over here for x is 3, 45, and then 7 and 2. Okay, and then for y we have 2. I'm writing these things over here, 54, 13, 15. Okay, so that's what we are going to use over there. So since we've created this function cosine similarity, we just use that one to calculate it. Okay, so let's run this one and then you'll see. Okay, now you see that we have a very strong cosine similarity between x and y. Okay, so if you think of x as bread, okay, if you think of x as bread and you think of y as butter, okay, so there's a very strong relationship between bread and butter, so we can make that kind of recommendation. Okay, remember this one, the cosine similarity ranges from 0 to 1. Okay, so this one is almost 1, right, almost perfect. Right, so that is a very strong relationship between or similarity between the two items. All right, and that's how we do it in Python. All right, now I'm also going to show you how you can actually build a content-based recommendation system. Remember, what we are doing is content-based recommendation system, which uses the idea of cosine similarity. Okay, so we're going to see how we do that in the next lab session. All right, so see you in the next lab session. All right, welcome back. Now in this tutorial, I'm going to show you one more concept that you need to understand when it comes to content-based recommender systems. Okay, so I'm going to demonstrate this one for you to get a better understanding of that. All right. Okay, so this is what I'm going to do. Okay, so in content-based recommender system, what we first do is to convert whatever data that we are working with from the unstructured form to a structured form. Okay, from unstructured form to structured form. And in this case, you'll be working on text, right? It's more of natural language processing concept over there. Okay, you apply the concept of natural language processing over there. But in this case, I'm going to show you how it is done. Okay, converting the unstructured data to structured data format over here, right? We refer to it as document term matrix. Okay, document term matrix or document term frequency matrix. Okay, you can call it this way, right? Document term frequency matrix. All right, then after you do that, then you calculate the cosine similarity, which is between what the user is searching and also the rest of the item or the rest of the products that you have. Okay, so let's see how that is done. First, we will see how we do this document term matrix. Then after that, we will see how we do the cosine similarity with regards to that. Okay, so let's say in this case we have a document repository where the users want to search something, right? Let's say a book title. Okay, they search for the book title and then we recommend similar books for them. Okay, all right, so we have document 1 over here, right? Or you can call it book 1 or book 2 or book 3. All right, so in document 1 we have the game of life is a game of everlasting learning, and then document 2 we have the unexamined life is not worth living, and then document 3 we have never stop learning. Okay, so let's say this is the documents that we have, and then this is the search query, right? This is what the user want to search. So the title of the what the user is typing is life learning, or the book that the user is searching is life learning, right? Now the question is, if the user type life learning, should we recommend this the first document, or should we recommend the second document, or should we recommend the third document? Okay, we need to know which one, right? For instance, if I go to Amazon and then I search, right, let me go to Amazon over there, and then I search for, say, from 0 to hero, or from 0 to 1. I think that is what I want. Okay, that's so from 0 to 1 is one of the favorite books that I like reading right now. If I search from 0 to 1, right now, what books should they recommend to me, right? What other books should they recommend to me, right? Now they need to calculate the similarity and then see which one relates to the one that I have searched. Okay, now if you see the first one, right, the rule of 1. Okay, now you see that we have the word 1 in there, right? So the keyword that I searched, there was 1 in there. Okay, there was 1 in there. That's the book title that I said. So the one that is very close to that one is this one. That's why it is the one that is appearing first. Okay, that's why it is the one that is appearing first over there. Okay, if you see this one, right, 0 to 1, right, it's also having something there. So all of these things, if you click on them and you go and read the descriptions, you see that they are having some keywords of these ones over there, and that's why they are appearing like that. Okay, so let's see how we're gonna do that. Okay, so if the user search this one, which one should we recommend? That's what we are trying to find out over here. Right now, what we need to do is to calculate the document term frequency metrics. Okay, and for that, this is what we do. So we look at the search query that the user has searched. Okay, and then we said, okay, in this search query we have life in there 1, we have learning in there 1. Right now, let me even give you an example over here. Okay, let's say that this is the, let me give you a new one, because this is just a 2 words in there, so maybe you're not understanding why you want 1 over there, right? So let's say I search something like he is the best person of all students in the class. He will be the best among the other students also, right? So I'm just giving a sentence over here. Now if you want to calculate the term frequency for this sentence that I've given, right, what you do is that you take each one of these sentences. So he will be 1, right? He will be on its own. Okay, and then so all these words are going to be in a form of in table columns, right? Column names over there. So space over here, ace will come. Okay, and then space over there we have space over there we have there, and then we have best, right, and then we have person. Okay, and then we have of, and then we have or, and then we have student, and then we have in, and then we have the. So we see that we have the here. Okay, so now when we encounter the again, we are not writing it, okay, because we've already put it over here, right? Let me give us a bit of space over here. Okay, so I move on to class, right? And then I move on to he, right? He has already appeared here, so I'm not bringing it. So I move on to real, all right? Then I move on to B. Okay, I move on to B. Then I move on to there has already appeared, so I'm not gonna. Best has also appeared, right? Among. I move on to among. Then I move on to there again. I'm not writing that one. We have already written it. So I move on to the to other. Okay. Then I move on to student. Now student has already appeared, right? It's actually students. Okay, it has appeared one here, so I'm not gonna write it again. And then also. So now I'm going to write also over here, right? Also, so these words are going to be junked together like this. I mean, junked on each column like this. Okay. So now we're going to over here, right? Let me push it. Let me push this one a bit. So here we're going to write something like here it's going to be the document. So I'm just going to name it docs. Okay, that is the docs over there. All right, and then here is going to be the term frequency. I'm just naming it as TF. All right, so now how frequent did he appeared? So he appeared 1, 2, right? 2. So he appeared twice, so you put 2 over there. And then is, right? Is appeared how many times? 1, right? 1 time. So is appeared 1 time, so I put 1 over there. And then there appears how many times? 1, 2, and then 3, and then 4. Okay, so over here I put 4 over there. And then best appears 1, 2. Okay, so I put 2 over there. Okay, and then person appeared what? 1. How many times? 1, just 1. Okay, so I put 1 over there. All right, and then off appeared how many times? 1 and 1. Okay, so I put 1 over there. And then all appeared how many times? 1. Right, it appeared 1 time, so I just put 1 over there. And then students appear how many times? Let me give a space a bit. Right, students appeared how many times? 1 and 2. Right, so twice over there. Right, so I put 2 over here. And then in appears how many times? 1. That's it. Okay, it appears 1 time, so I put 1 over there. And then class appeared how many times? 1, and that's it, so I put 1 over there. And then real appeared how many times? 1, so I put 1 over there. And then B appeared how many times? 1. Okay, so I put 1 over there. And then among appeared 1 time, so I put 1 time. I put 1 over there, right? And then other appeared how many times? 1 time. Okay, only this part. All right, so I put it over there. And then also appeared 1 time, so that's, I put it over here. Okay, so that's how you do the term frequency. Okay, that's how you calculated the term frequency. All right, so now let's relate that one to what we were doing over here. All right, so we have our search query, which is the live learning. Okay, and then live, in this sentence, live appeared 1. Okay, that is the term frequency. And then learning appeared 1. Okay, that's why I have it here. Now if we pick the document 1, right, if we pick the document 1, right, which is the game of life is a game of of everlasting learning, right? That's what I'm doing over here. The game of life is it's a everlasting learning, right? So over here they appeared 1 time, so I think I missed something. The game of life is a game of everlasting learning. The game of life is a game, so the game is already here, so I'm not going to repeat everlasting learning. Okay, so that's fine. So now, so they appeared 1 time, right? So if you go and see, we have the which appeared only 1 time, right? And then game appeared twice. Okay, game appeared twice. Game. Okay, so that's what you're seeing over there, right? And then off appeared 2 times, right? Which we can see over here, off and then off. All right, and then is appeared 1 time. Appeared 1 time, everlasting and learning. Okay, So this is how you do it. So document one and the term and frequency, the search query and the term and frequency has been calculated. So now the next one that we need to do is to normalize what we have here. Okay, now over here, if I give you this one, right, and I say that they appeared one time, right, now what you get to know that they appeared one time, but out of how many words did they appeared one time? Okay, that's the information that this one will not give us, and that's why you need to normalize it. Okay, that's why you need to normalize it. And for normalization, what we do is that we count the number of words that we have in the sentence, the entire sentence. Okay, so in the entire sentence, we were having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10 items over there, right? So they appeared one time in the 10 individual words in the sentence. Okay, so here, if we are going to normalize it, right, then we have to divide 1 by 10. Okay, in the same way, if we pick life over here, life appeared one time in two words in the sentence. Okay, so it will be 1 divided by 2. Okay, that's what we're going to have here. Okay, it will be like this. Let me just do it in this way. So it will be for life learning, right? If we pick, say, life, how many times did life appear among the entire sentence? Okay, so we were having 2 words in the sentence, and life appeared one time, so it's 1 over 2, right, which is nothing but 0.5, right? It's 0.5. Okay, which is the same. I'm talking about 0.5. Okay, or you can also write 0.5. So if you see that I've written 0.5 here, it's just the same thing as 0.5. Okay, it's just the same thing as 0.5. All right. Okay, in the same way, if you pick this one, right, they appeared one time out of 10. Okay, so that is gonna be something like 1 out of 10. Okay, 1 out of 10, which is nothing but 0.1. Okay, this one appeared 2 times, so it's gonna be like 2 out of 10, right, which is nothing but 0.2. Okay, so we do it for all of them over there, right, for all of them over there. Okay, so let me get rid of this, and I hope you get to understand what we did over there. All right, now what we do next is to fish out those items that are of interest to us. Okay, so this is what the user is searching, right? That's the search query, right? The search query the user is searching is life learning. Okay, that's what the user is searching. Now in the document one, that's the only thing that we're gonna focus on over there, right? So we're gonna see life and then the learning. Okay, which here we have normalized all of them, so we're gonna just fish out the life, okay, and then the learning. So that's what we are doing here. Convert doc1 to a shorter form. So I'm just in document 1, I'm just selecting life and then learning, right? And their frequencies are 0.1 and 0.1. You can see over here, life frequency is what, 0.1. Learning 10 frequency is what, 0.1. Okay, that's what I'm doing over here, right? So now I have this one, then I have this one as well. That's the search query and also the document that we want to compare with. All right, now once we have we have both of them, now we can calculate the cosine similarity. Now if you remember in our previous video, we talked about the formula for calculating the cosine similarity, right? Where we talked about that is a dot product of x and then y, right, divided by the absolute value of that, okay, and multiplied by y, right, multiply by y the same way like that, okay, which we expanded to something like these ones being individual of x1 multiplied by, say, y1, something like that, plus, say, x2 multiplied by y2, something like that, okay, all the way to the last item over there. All right, and then the denominator was something like the summation of all the i's, right, squared, right, and then you find the root of that and you multiply it by the summation of y, okay, squared, that's all the y's, okay, and then you find the root of that as well. So this is what this is the formula that we're doing. So that's what I'm going to do over here, right? So cosine similarity of d1 d2. So d1 represents document 1, that is the search query, okay, is a search query that we are looking for, which is this one that we have done, and then d2 represent the document 1 that we have, okay. So you can represent this one as x1, x and then y, okay, where x represent this one, okay, and then y represent this one, okay. That's what you're gonna do, which is the dot product of x and then y. So that's what you're going to see over here. divided by this, okay, divided by what you see over there, right? That's the same formula, which translates to d1, right? The item at 0 0, right? You multiply that and the plus, just the same way, right? So you can call this one x0, x1, y0, right? And then x1 multiplied by y1 right, plus x2 multiplied by y2 all the way to the last one. So that's what I'm doing over here, right? And then for the denominators, which is this one and this one, we expanded it to this one, okay? So that's what I'm doing, square root of, okay, which is this one, square root of all the x's squared, okay? So all the x's squared is just gonna be like that, d0 squared, right? d1 squared, d2 squared, d3 squared, like that. That's what you're gonna have here. And the same way, the same thing for this one. So that's the formula that I've put over there, right? Now over here you can see that I have dot product of test doc and then document one, right, which will represent our x and y, as I said. All right, so we're gonna do it for that. And the text doc, we've normalized it to this one. For document one, we've normalized it to this. Okay, all right, so that's basically what we're doing over here. So for the numerator, it's gonna be 0.5 multiplied by 0.1, which is nothing but this one multiplied by this one, right? And this one also multiplied by that one, right? And then you find the addition of that one, which is gonna give you 0.1. okay? And then for the denominator, right, it's gonna be square root of the x squared, so it's gonna be 0.5 squared plus 0.5 squared. So that's what we're going to see over here, 0.5 squared plus 0.5 squared, and this is the value. And then for the y, or for the document one, we're going to have 0.1 squared, 0.1 squared, okay, like that. And then you find the square root of that. All right, and this is what you have. Okay, let me get rid of this one and then push it up for you to see. So once you do that, then what is left is to just put them together. So over here you can see that I'm putting the 0.1 that we have, which is for the numerator, right, divided by this one multiplied by that one, okay, just like that root x, all the x's squared, right, multiplied by the root of all the summation of all the y's squared. So that's basically what I'm doing. All the x's squared are the value of this one, all the y's squared are the value of this one, and that's what you're seeing over here. And finally I'm getting 1 over here for the cosine similarity. Okay, so our cosine similarity, right, cosine similarity is equal to 1, which saying that they have a very, very high similarity between them. Remember, the value ranges from 0 to 1, and the closer to 1, right, the stronger the relationship or similarity, and the closer to 0, the weaker the similarity. Okay, I'm just using negative here to represent weak similarity and positive here to represent high similarity. Okay, so that's basically. So for 1, if you do the calculation and you get 1, it means that they have a very strong similarity. Okay, over there. All right, now I did it for document 1, right? I did it for document 1 and the search query. So now you can do it for the search query and document 2, okay, and document 2 as well as document 3. Okay, so that you also get hands-on and then you get to understand what you're doing, right? You can just rewatch how I did this one, right? Just rewind the video and then watch it again to see how I did it, and then do it for document 2 and document 3. All right, welcome back. Now in this particular tutorial we're going to start with collaborative filtering. So in the previous videos we have seen different kinds of recommendation systems, and in this particular video we're going to focus more on collaborative filtering. Okay, so I want to compare the collaborative filtering with the content-based filtering so that you get a clear understanding. Okay, so in the content-based filtering we say that the user will engage in one content, and then we look for similar content, and then we recommend that similar content to the user. All right, now for the collaborative filtering, what we do is that we base on other users, right, what the other users are doing, and even with the past activities or records of the user, right, and then we base on that to do the recommendation. Okay, so for instance, if this user has read this document, okay, we can recommend this same document to this user based on certain things that these two users have in common. Okay, so they will both end up reading the same document. Okay, all right, so this user has read certain document, and at the same time this user has some commonalities with this person. Okay, so based on that commonalities, we can base on that and then recommend the same document to this person. All right, so that is collaborative. Okay, it's kind of a collaborative work instead of this one where it is solely based on the person, right? This is more personalization, but this is more of a collaborative work. Okay, so I hope you have the basic idea of collaborative filtering. All right, so these are the two main scenarios where we employ collaborative filtering. Okay, so we might want to ask ourselves, how can we measure the similarity between two users? Okay, so for instance, we're talking about this person having something in common with this person. Okay, so we want to know how we can measure the similarity between these two users so that we can base on that similarities and then recommend things that one is liking to the other. Okay, so if you come here, we also want to know how can we measure the similarity between two items. Okay, so over here, that's what we're doing in content-based filtering. Okay, based on the similarities between the two items, we made the recommendation. Okay, and here, based on the similarities between the two people, we make the recommendation. Okay, so content based or item based, and then person based if you want to, right? And then based on their similarities, we recommend products to them. All right, okay, so I'm going to take you to the lab session so that we see a hands-on of this collaborative filtering. All right, welcome back. Now in this tutorial, we're going to see how we do we evaluate the various recommendation systems that we have. Okay, so recommendation systems, as we have seen so far, right, they are not different from what we were doing earlier on, right? Just that their outcome is quite robust and their results is very incredible. Okay, the outcome is very incredible. So that is basically what we make them more prominent in the industry, right? But you can use either classification or you can use regression metrics to evaluate your recommendation engines. Okay, so previously we have seen several evaluation metrics over there, right, including the root mean square error, the mean absolute error, the accuracy, the ROC, AUC, right, precision and recall. We have seen all of that. Okay, so either of these metrics, evaluation metrics, you can use them to evaluate your recommendation systems. Okay, so for instance, if we want to evaluate this one that we just did, right, we can use any of these evaluation systems. Okay, so over here I'm going to use the X that we have over here, right, because over here I cannot use this single one, right? Remember that the model we built it using the X, right? So if I want to compare that one, right, if you're measuring the accuracy, it means that we need to compare it with the original values. Okay, so the size must be the same, right? That's why I'm going to use the original X, right? I'm talking about comparing what we are going to predict with the original Y. Okay, so these two, the size must be the same, right? So you cannot use a single a single array like that and then you want to compare it, right? It must be of the same size. Okay, so over here I'm going to run this one, right, and here I'm going to use a classification report. Okay, so we see that we are doing some predictions over there, right? So I'm going to use a classification report for this purpose. Okay, so let me run this one over here. Right now you can see what we are doing over here, right? You can see that some of them, if you see precision, right, you see precision for 0 is 90, but if you see precision for 1 is 67. If you see recall is 99, but if you see recall for 1, 17, that is really bad, right? It's absolutely terrible, right? If you see F1 score, right, you can see that for 0 is 94 and for 1 is 27, right? So you can see that there's something wrong over here, right? It's the model is actually predicting most of the time of the zeros and then ignoring the ones. Okay, and you can actually figure out what the problem is. Okay, if you see the support over here, right, you can see that the zeros are 39,922 whilst the ones are 52,000, right? So is the problem of data imbalance. Okay, is the problem of data imbalance over there, right? The model has realized that at most of the time we have majority of the data points to be zeros. So why don't you just memorize all the zeros and then forget about the ones? After all, most of the time you're going to encounter zeros. Okay, so that is what is happening over here. If you check the value count, you will also be able to confirm it over there, right? That's the problem of data imbalance. So what you can do is to go back and then use the data imbalance techniques that we learned earlier on, right? The upsampling and downsampling techniques to upsample the lower class over here to match the upper class, okay, so that you rebuild the model and then do it again. All right, yeah, we just run the same process that we have just done. Okay, so the evaluation metrics are just the same as we've used so far in the in the machine learning class. All right, so I hope you have enjoyed the recommendation system tutorial, and keep practicing, especially the ones we did earlier on are going to be very, very helpful if you want to make a career in recommendation systems. As I said, it's a very, very incredible and exciting field to be. If you want to master that part, is great. Okay, it's great. So keep practicing and be better at it, right? And then also engage in the projects that we're going to do in the future, and even be as creative as you can to do a lot of projects on your own, right? And be implementing the concepts that we have learned so far, right? And don't forget to give a good rating and a good review to the course. Right, see you at the Q&A session. Have a nice day. All right, welcome back. Now in this particular tutorial, we're going to see you're going to get a hands-on on the content-based recommendation system. Okay, so in the previous tutorials we have a lot of understanding of what content-based recommender system is, and we've learned about cosine similarity and also what is known as the document term frequency matrix. Okay, so we're going to implement those concepts over here, right? So this part is in regards to the previous one where we learned how to calculate the cosine similarity. Now we're going to use a data set over here and then do the same thing, right, and see how we can make some recommendations using the concept of content-based recommendation system. Okay, so what we're going to do is that we're going to have this. We're going to go to this URL, okay, and then import some data set over there. Okay, this is a movie data set which is going to help us make some recommendations, right, based on some similar plot and general director, right, etc. Okay, so for instance, if we have a movie like, say, if someone comes and then the person search for movie like Titanic, right, we should be able to based on the keyword that the person has typed, right, and then recommend similar movies, right, based on the plot in Titanic and the directors in Titanic and the actors in Titanic. Okay, we need to be able to base on that and then make the recommendation. So let's see how we're gonna do that. Okay, so of course I'm going to load my libraries over here. Okay, and here you can see that I'm using what is called cosine underscore similarity. Okay, so whatever function that we did over here, right, Python also has that inbuilt function. Okay, it has already been inbuilt in Python for you. You don't need to do anything. You just have to do from sklearn.metrics.pairwise. Okay, then you import cosine similarity, which we are going to use. And then for document term frequency, like the way we're doing over here, right, where we're calculating the document term frequency like this, right, where we did it for document and the keyword the person is searching, and also for the term frequencies. Okay, for that we are going to use what is called count vectorizer to do that. Okay, we're going to use count vectorizer for that purpose. Okay, so we don't need to do this thing manually like we're doing over here, right? This one was to give you an understanding of how things work. Okay, but Python has an inbuilt function over there which we are going to use. All right, then what I'm going to do is that I'm going to load this data set from this URL. Okay, so this is the data set. Let me just rerun it for you to see. Okay, great. So the data set is having an index column, which in this case it was not able to detect it, but it's just an index like the way pandas has also given us an index over here. Okay, and then the title, right, the title of the movies are there, the year the movie was published is there, the rated, whether the movie is rated or not rated, right. The rated is also over here. Okay, how the movie is rated is here, the release date is here, the runtime, general, director, writer, actors, plot, language, country, awards, poster ratings, and so on and so forth, right, all the way to the last one, which is response. Okay, so it's kind of a lot of features over there, right. If we check the shape of it, you can see that we have around 250 records with 38 features. That is too much over there, right? That is too much of a feature over there. Some are relevant, some are irrelevant in doing this kind of a case. And that's as usual, as a data scientist, you need to, or machine learning engineer, you need to know where to clean and what features to select. Okay, in this case, we're going to use the title, the genre, the director, the actors, and the plot. Okay, we're going to use based on that to make the recommendations that we're going to make. Okay, so that's what I'm selecting over here, and then I'm storing it in DF, right? So if I show you the head of it, you can see that we have the title, genre, director, actors, and then plot over there, right? Okay, so next, what I'm going to do is that we're going to do some text processing over here, right? So if you go to the actors column, right, the actors column, we have the actors to be like this. So we have for instance Tim Robbins, Morgan Freeman, Bob something, and over there, right? So what I'm going to do is that later on I'm going to put everything when we're doing something like this. Okay, when we're doing these 10 frequencies, right, we see that we count each one of these items that are appearing. Okay, so what I'm going to do is that I'll finally create one column over here which is going to contain every item over here, which we are going to use the count vectorizer library that we imported, right, to do that TF I mean 10 frequency over there. Okay, so we're going to do something like that. So that's what I need. That's why I need to process this column over here, which is the actors column. So for instance, there are a lot of actors over there, but I'm going to pick the top 3. Okay, I'm going to pick the top 3 actors. There's nothing wrong with picking all of them, right? I just wanted to make this code run as fast as possible. Okay, so that I will not extend this video, but I mean the understanding is just the same thing. So instead of top 3, you can just ignore that one. Okay, so that you use all the names over there to do it, right? Then I'm splitting it based on the comma that is in between them. So Tim Robbins is one actor, Morgan Freeman is one actor, and so on and so forth. So I'm doing that one based on the actors that are there, right? So if let me run this one. So if I show you the actors that I have over there, right? So these are the actors that I've selected, or the top 3. So Tim Robbins, Morgan Freeman, and then Bob Cotton. So these are the ones that I've selected. It's the same thing for all of them, right? So now once that is done, what I'm going to do is that for the genres, right, for the genres, if you go into the genres, you can see that we have the name C to be capital, D to be small, right? So I'm going to convert everything into small letters, and I'm also going to split it based on the comma in between them, just like I did it for this one, right? And then even the actors, right, actors too, you can see that some of the names start with capital, some of them also start with small. Okay, it's possible that some of the names have been spelled in full capital, some of them have been spelled in this way that you see, and some of them have been spelled in small letters, right? And Python is case sensitive. So for instance, if someone's name is spelled like Robbins, right, like this, Python would treat this name differently from someone whose name is the same person whose name they spelled it as Robbins. Okay, so the same person, they spelled the name capital, the same person, they spelled it small. So it's gonna be just a duplicate actor who is being repeated several times in there. Right, so in order to, one of the good text processing skills that you need to master is that you need to convert everything to lowercase, right? So in general, for instance, I have crime starting with capital, drama starting with capital. I'm going to convert everything to lowercase over there. Okay, so if I run this one for you to see. All right, great. So let me show you genre. Now see that I have crime small, drama small, everything will be small letters. So it won't be like there will be duplicates over there, right? There will be duplicates, especially for, say, the actors. Okay, I'm going to do the same thing for the actors and the directors right here. I'm going to convert everything to lowercase over here. But first, let me also deal with the directors as well. All right, so for the directors, I'm just gonna select everything. But directors, you see that the name, I have Frank space and then Darabont, okay, and then Francis space Ford space Coppola. Okay, so in that case, what I'm going to do is that I'm going to split it based on the spaces between them. Okay, based on the spaces between them, right? So let me run this one, right? You get to understand why I'm splitting these things right after I finish with this one. I'm going to use them, as I said, to put all of them together so that we can be able to do the count vectorizer on them, right? So as I said, I'm going to convert everything, the actors, right? I'm going to convert everything to lowercase, right? For every item in the actors column, I'm going to convert everything to lowercase. And then for the space, also for the directors, right, what I'm going to do is that I'm going to put them together. Okay, so instead of having the director name like say Frank, right, Frank Darabont. So if I'm to use this one, Python is going to treat this one as one actor, okay, and then another actor. But meanwhile, Frank Darabont is just one actor. Okay, so what I'm going to do is to join both of them, right, to join them on nothing, so that there won't be any space in between them, right? So let me run this one, you'll get to understand, right? So for the actors, if I show you the actors now, you see that they are all small letters. That's what I did for the actors, okay? And for the directors, I put everything together. So if I run it for you to see, you see that Frank Darabont is put together like that. Okay, so I know that this is one actor. Okay, this is one actor. And then for instance, Francis Ford Coppola is put together like that, instead of having it here as if you see the director, right, Francis Ford and then Coppola. Okay, it shouldn't be like that. They should all be put together like that, so that we'll be able to treat them as one. All right, so once this is done, we're going to use one more important library here, which is called rig_NLTK. Okay, this is a natural language toolkit. Okay, NLTK, natural language toolkit over there. But we will use more of NLTK when we go to the natural language class. Okay, where we are going to deal purely with text. Okay, where we're going to do a lot of text processing and stuff like that. We're going to see more of NLTK over there, right? But for now, since we are working with text, I'm bringing it over here, right? And this rig is actually going to help you extract keywords, important keywords from the words that we are going to put together. Okay, I told you that we're going to put together everything that we have on our data set, right? For instance, the title, the crime, the genre, the director, the actors, the plot. We're going to merge all of them together so that we do the count vectorizer like we're doing over here. Okay, so that's why we need this one, so that we'll be able to extract the important keywords and then ignore those that are not important, and based only on the important keywords to do the analysis that we're going to do. Okay, so if you don't have this one, you have to run this code over here, right, so that it installs it for you. I have already installed it, so it's telling me requirements already satisfied. But if it's your first time, it's going to install it for you. All right, so once that is done, then you can import it. Okay, so import rig_NLTK, and from here, and then you come here and you do from NLTK import rig. Okay, rig is the one we're going to use to extract the significant keywords later on. Okay, now over here I need what is called stop words, because in rig we have what is called stop words, and we have this pan-kt over there, right, which we will use later on in the natural language class. But stop words are nothing but words like the, this, is, and those kind of things that we say frequently, but they don't really contribute much. Okay, when I do the extraction of the keywords, you'll get to understand what I mean by that. All right, over here I'm going to extract those keywords. So in my data set, I'm going to create one more column, which I'm going to call it keywords. Okay, let me actually run this one so that I will explain it alongside the output. Okay, so if I run this keywords dictionary score, right, it's nothing but it's nothing but it's here, right? I'll come to it later on, but I just want to show you what we are doing. Okay, all right, so if you see here, you can see that out of the keywords, all the keywords that are there, the rig function will go through and then extract these important keywords. Okay, so for this particular movie, accused, cheating, Indian, millionaire, Mumbai, reflects, slums, teen, bringing, version ones. Right, these are the important keywords that are in that particular movies. That's why it's extracting that for me, and you can see that it's assigning some scores to them as well. Okay, so that's what this part of the code is doing. I'm assigning I'm creating a column over there, right, in our df called keywords. Okay, so if I show you the df, what we have in df, let me run this one. Okay, in the df you see that I have keywords, and this keywords contains everything that we have. Right now, once that is done, what I'm going to do is that I'm going to create some keywords over here in my df. I'm going to add this keywords column to my my data frame over there, right? So I'm just initializing it to nothing, because right now there's nothing over there to put in the keywords, but I'm going to use this rig that we just imported, right? We're going to use that rig to extract keywords from the plot. Okay, so on the plot column, right, in our data set, if you go all the way up here, right, we have plot over here. So in this plot that we have, right, I'm going to extract keywords from this plot. Okay, because the plot, this is a long description over there, right, and I don't want all this long description. Later on, what I want to do is that after I have extracted some keywords from this one, I'm going to add it to the actors, to the directors, to the genre, to the title, right, and all of them I'm going to add it as one column over here. Okay, so I don't want to add all these plot descriptions over there. Only the important ones that are that are here is what I'm going to select. Okay, that's what the rig function is going to help us do, right? So it's just going to extract those important keywords over there for us. Then once it extracts that keywords for us, what I'm going to do is that here too we have degrees. Okay, because if it's to extract keywords, it has to know which ones are important and which ones are not. So rig will actually assign degree of importance to the words that we have over there before extracting it. Okay, so those degree of importance, I'm storing it in keywords underscore dict underscore scores. Okay, now once I do that, I'm going to get all those scores over there, right, and the keywords, and I'm going to store it in in what is called keywords, right? And what I'm doing is that earlier when I said that for index and the row in df.iter rows, okay, so I'm going to iterate, right? I'm going to iterate through this one. Okay, I'm going to iterate through this plot, right? Each of the rows I'm going to iterate. So if I go to the first row, I extract the keywords, then I go to the second row, I extract the keywords, I go to the third row, I extract the keywords, all the way to that I reach the end of it. Okay, that's what I'm doing over here, right? So if you come all the way here, that's what I'm doing over there, right? Okay, that's what I'm iterating all the rows in the plot. Okay, so once I get the keywords, right, once I get the keywords, I'm going to add it to the row that I have over there, right, as a new column over there. Okay, then once I have extracted the keywords, I don't need the plot anymore. Remember earlier on I told you the descriptions are too much in the plot column, so that's why I'm extracting only the important keywords over there, right, and their degree, right, so that I'll be able to drop that column, right, and then use the only the important keywords I've been able to extract from that column. Remember when we are doing the normalization, right, when we're doing the normalization, we only selected those that are important, not all of them, right, not all of them. For instance, is over everlasting and all those ones were not important to us, off and stuff like that. So we only selected the life and the learning. Okay, that's the only thing that I'm doing. So in the plot, I'm only selecting the important keywords, and I can't do it by hand like we did it by hand over here, right? I can't do that one by hand like we did, because this one was just small. The game of life is everlasting learning. It's just a very small sentence over there, but the description here is very, 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 very long and tedious to do by hand. So that's when the the rig function will come in to help us do that. Okay, so now once I do that, let me show you. Let me go, and then I need to rerun whatever that is here. So I'm just gonna do this and run everything before. Okay, so now I'm going to run this one again. Okay, great. Now you see that we have the keywords that we're able to extract. So if, for instance, for this particular row, right, it's a particular movie, but on the plot, right, inside the plot description, these are the important keywords, right? Accused, cheating, Indian, millionaire, Mumbai, reflects, slums, teen, upbringing, version ones, and their degree has been, their degree of importance has been assigned over here, right? So that's what we wanted to do, right, to be able to extract those important ones, right? Now once we do that, what I'm going to do next is to set the title, right, the title in our df. So let me show you what we have in df. Okay, so df, let me run it here. right? In DF, if we have the title and the other columns over here, and then we have an index over here, but I want this title to be in the index, okay, so that I can, based on that title, if I want to say Godfather, I can select Godfather, and then together all the other information of Godfather will come alongside. Okay, so that's why I need this one. I need to set the index to that. So now you can see that the index, the title is now the index, instead of having this ones as an index and this one being the column. Now the title is now the index. Okay, next what I'm going to do is to do what I was talking about earlier on, right? I'm going to create another column named as bag of words. Okay, and bag of words is nothing but a combination of everything that we have. So I'm going to put together crime, drama, Frank Darabont, the actress, the keywords and everything, right? I'm going to put all of them together as a single column. Okay, so that we'll be able to do this term factorizer on them. Okay, we'll be able to junk them like this and then do the term factorizer on that single column, right, which contains all the information. Okay, so I'm creating this DF column over there, and right now I don't have anything in there, right? And once I finish, I'm going to put whatever that I'm going to do down here inside that column. Okay, so I'm going to create a variable here called columns, which is going to contain all the columns that I have over here. Okay, now once I do that, I'm going to iterate through all the rows and the index that I have over there. Okay, and then I'm going to create this empty string over here, which is words, which is going to contain the words that I'm going to select. Okay, now what I'm going to do is that I'm going to select each of the words that I have over there, right? So let me show you from here, right? So if I select these words, crime and drama, I want to add it to the director, I mean whatever data that is here, Frank Darabont, right? And I want to add it to this one, and I want to add it to this one. So that's what I'm doing over here. Okay, that's what I'm doing over here. So if I select, I add it. If I select, I add it like that. Okay, and then finally I'm just going to drop all the columns which which are there, because I don't need them. I've already put all of them together, right? Let me actually run this one so that you get to see what we have now. All right, now you see that I have only the title and then bag of words column over there, but this bag of words contains everything, right? It contains, you see that we have crime, drama. If you go here, that is the column for the genre, crime, drama, and then the director column starts with Frank Darabont. You see that is there, Frank Darabont, and then you move to the next, which is Tim Robbins, Morgan Freeman, Bob Gatton, and so on and so forth. You see that Tim Robbins, Morgan Freeman, and so on and so forth. So I've put all of them together like that, so that now we have something which looks like this. Okay, something which looks like this sentence, or right, one long sentence like that, which we are going to junk together, I mean differently, separately like this. Okay, we're going to junk it separately like this. So that's what I'm doing over here. All right, now once I do that, now I'm going to use the count factorizer to count how many times did say they come. I'm actually doing this one. How many times did say they appeared? Okay, so in this case they appeared one time. Okay, they appeared one time, so you're going to find it like this. Okay, how many times did they appeared? So that's what I'm doing, but I can't do these things by hand. Okay, this is quite a lot of things over here, so I'm using what is called count vectorizer. Okay, that's what I'm using. I'm just initializing it to count, and I'm using count.fit over here, right? And I'm fitting it on the bag of words which I've just created, right? So let me run that one. So if I show you what is inside this count matrix, okay, it contains 5,341 in items that, or elements that have been stored over there, right? Let me show you the tudens over here, right? I'm using count matrix.tudens. That is whatever that I've created here, right? And then I'm storing it in C. So let me show you what is inside there so that you get to see what we did. Now you see that we have 0, 0, 0, and then here is broken, and then some 0, 0s here. Okay, so for instance, if we go through and then we did not find any there over there, right, it's going to put 0 over there, but there will appear somewhere else, and that will be 1. Okay, let me show you this part as well, right, so that you get to know. Okay, if you pick the first row, right, the first row, 1 appeared at column 584. Remember, we have these ones, right? This one is up to, we have 5,342 columns. Okay, 5,342 columns over there. That's why I was saying you can't do these things by hand. If you want to do it by hand, it will take you a lifetime to do it. Okay, So in column 1, which is column 0, right, Python, due to Python indexing, right? So Python will index column 1 as 0, column 2 as 1, column 3 as 2, and so on and so forth. Okay, so 1 appeared at row number 584. Okay, and it also appeared, 1 also appeared at 768, 1 also appeared at 1011, 1 also appeared at 2006, 2678, right? So and so on and so forth. All right, so that is how it's gonna be like, right? You're seeing 0 here because there's a break here and there's a break here. Okay, but it's quite a lot of data points for this one to display. Okay, but that is basically the idea over there, right? Now once I do that, once I've been able to do these things, right, once I've been able to do these things, I'm going to use this cosine similarity, right, on that, okay, to calculate it. So here I'm using cosine similarity, and I'm passing in count matrix and then the same count matrix. If you see what we're doing over here, right, in cosine similarity, right, we put in the text doc and then the document one. Okay, here we are comparing the text doc with the document one. Here I'm comparing the count matrix with itself, right? For instance, if you pick Titanic, right, if I pick Titanic from here, I want to compare Titanic with other movies that are in the count matrix that we have created. Okay, so we can match Titanic with another movie which is also tragic like that, okay, in the same count matrix that we have. Okay, if I show you what we have now, okay, so we have these count vectorizer, cosine similarities for the various movies that we have in there. Okay, we have the cosine similarities. Okay, now based on their cosine similarities are what we are going to base on to do the recommendations. Okay, now what I'm going to do next over here is that I'm going to create what is called index, right? I will use this one later on, right, to do the matching. If I want to match a certain movie, I will base on the index to do that. Okay, so let me create this one. We will come back to it. Okay, if you see the output that we have over here, right, if for instance Godfather here, if I'm searching for Godfather, I can search the index 1 and then I'll get Godfather. If I'm searching for, say, the Dark Knight, I can search for index 3 and I'll get Dark Knight. Okay, that's what I'm doing over here. Right, now finally I'm going to create this recommendation function over here, okay, which is going to contain the title, okay, whatever title that the user is going to give. Okay, then I'll compare that one with the cosine similarity matrix that I've created over here. Okay, I'll compare with that the cosine similarity values that I have over here, and then based on that do the recommendation. Okay, now I'm going to create this empty list over here, which I've named as recommended movies. Okay, and then what I'm going to do is that if I go into the index, okay, over here, right, if I go into the index, if I pick any of the index, right, I match it with the title, with the respective title. Okay, that's what I'm doing here. If I pick any of the index, I match it with the respective title, and that is going to store in a variable called IDX, nothing but the index of that title. Okay, and then I'm going to go into the cosine similarity to look for that index over there. Okay, and then sort it. Okay, and then I'm saying that ascending equals 4 so that I get the highest cosine similarity. So for instance, if I pick Godfather here, Godfather's index is what, 1. Then I go into this one, right, and then I look for index 1 over here. Index 1 will be this one, right? Remember how pandas indexing works. This one will be index 0, index 1. So over here, these are the cosine similarities over here. Then I sort these cosine similarities from the highest to the smallest so that I know which one is actually having the highest cosine similarity. Right, remember, the higher the cosine similarity, the more similar the movies are. Okay, so once I get that one, then I know that I have the title, I have the their cosine similarities. So what I want to do is that I want to output that cosine similarity. Let me actually run this one alongside so that you get to know. Okay, so once I get the title and I match it with the cosine similarity, right, I want to print out the top 10 of that. Okay, so that's what I'm doing over here, right, the top 10 over here. Right, and I'm going to get that one from score series, which is nothing but what I stored over here. Score series, which is the index that I've matched in the cosine similarity. I select the top 10 in cosine similarity over there, right, and then I print it out. So over here, when I supplied the name Godfather, right, these are the movies, the top 10 movies or the top 10 indexes that match with the cosine similarity numbers that are that I've sorted, right? For instance, if you come over here, right, Godfather is at index 1. Okay, so at index 1 here, right, I'm going to sort these things out. When I sort it out, I'll be able to know. Remember, this one is quite a lot of cosine similarities over here, so I sort all of them according to from highest to the smallest. Okay, then once I do that, I'll be able to get their index. For instance, if this one is higher, okay, if this one is the highest, right, 0.36 is the highest, so this one is at index 012, so this one is at the index 2. So if you come here, right, when I supplied it, you see that it's index 2. Okay, that's where the highest is. Okay, and the particular movie that was there at index 2 is the Godfather Part 2. Okay, now you can see that Godfather Part 2 is actually supposed to be highly correlated with the Godfather. Okay, it should be, even in human intuition you can think of it that the Godfather Part 2 is actually very, very similar to Godfather. Okay, it's just a part 2 of this one, right? Then at index 6, okay, at index 86, okay, so at index 86 in this one, in cosine similarity, right, remember this is broken, so I cannot actually see what number is there, but at index 86 is the next one, which was the highest, right, and that was the movie over there is Scarface. Okay, so that's basically what this function is outputting. So depending on the particular movie that you're going to supply to the function that we created, okay, this function that we created is going to give you the recommendations respectively. Okay, so for this one, for the Godfather, you can see that these are the recommendations. So these are the movies that are related or similar to Godfather. Okay, if for instance, if I search for, say, Fargo, right, let me search for another movie here, Fargo. Right now, see that earlier on Godfather was related to Fargo. So you see that when we search for Godfather, Fargo was recommended. Now when we search for Fargo, Godfather is also recommended because they are similar. Okay, and then Godfather Part 2 is also recommended. Okay, now see No Country for Old Men, right, that is also recommended because that No Country for Old Men is actually related to or very similar to Fargo. Okay, let me even go to my Netflix over here, right, and then I'm going to search for this one on Netflix, and we will see if this recommendation that we've created is actually working. All right, so this is Netflix, as you can see over here. So I'm just gonna search, say, Fargo, and then see. Let me I think it starts with caps, right? Okay, now you see the recommendation. Now you see Fargo is here, No Country for Old Men, right? Now if you go to what we're doing, right, you see that was there, No Country for Old Men. You see that was the recommendation that is given us. Okay, that's the recommendation that is given us. So you can see that what we are doing is working, right? Of course, some of the movies are new over here, which also relate to Fargo. Okay, which also relates to Fargo, and the data set that we are using is it's a quite old one, right? But if we get the new one that Netflix is using, we will be able to recommend it without any mistakes at all, right? But you can actually see that it's working. Okay, so which means that no Country for Old Men is still existing in Netflix. Okay, it's still there in Netflix. So and it was there in this movie data set that we are having. Okay, that's why you can actually see it over there. All right, so you can just do it for as many as you want, right? Over here I was just checking to see those ones. So for instance, this at index 132, right, at index 132, if I say I'm searching this index in this, right, in this index that we created. So at index 132, what is there, right? I want to see what is there. Okay, you see there's No Country for Old Men, so it will match it with that the title of the movie. Okay, it will go into the index and then match it like that for us. So that's why we're able to extract it and make it perfectly like that. Okay, so that you see how content-based recommendation actually works. Okay, based on the what the user supplies, they do the recommendation respectively. So in this case, Netflix is using content-based over here to give us, right, and of course they are not just using one recommendation engine. They are combining. We have what is called hybrid recommendation system. We are going to see it in the upcoming session. Okay, how that one also works. Okay, you're going to see how that one also works. Right, they combine a lot of recommendation systems to do it. But this one, you can see that is content based, which is doing this recommendation for us. All right, on Netflix. Okay, so this is content based, and I hope you have enjoyed this kind of tutorial. Right, so just spend time, re-watch it one more time. I don't expect you to get everything when you watch it once, right? Just do it one more time, and then practice it one more time, especially if you want to specialize in recommendation engines. It's a lucrative and very, very interesting career to have. Okay, so you can spend some time, go over what we have done so far. Right, in the upcoming session, we're also going to see a different kinds of recommendation systems. Okay, and please don't forget to give a good rating and a good review to the course. Okay, that's the motivation enough for me. All right, and don't forget to post your questions and your comments at the resource session, at the Q&A session. Okay, I'll be there to respond to every question and every response that you provide. All right, so see you in the next tutorial. Have a nice day. All right, so over here we're going to see a hands-on of the collaborative filtering that we just talked about. Okay, so we said that we have the user collaborative filtering and then item collaborative filtering. Okay, so when we want to measure the similarities between the users, okay, and then based on that similarity we do the recommendation, or we can also measure the similarities between the items, and then based on that we make the recommendation. Okay, so for instance, if we want to make a recommendation to this lady over here, whether she's going to make a purchase or not, okay, so we can ask ourselves, right, that based on the existing customers and product data, will this new customer purchase an insurance deal or not? Okay, so we have some user and then item attribute data which we already have. So based on the data of this user, right, can we compare it with what we have and then see if this person is likely to make the purchase or not? Okay, can we make that kind of recommendation based on the data that we have? Okay, or based on the purchase history of this customer, will she be interested in our new offer? Okay, so maybe this person has bought something from us before, right? So based on how this person buy things, her purchasing power, her purchasing behavior, and things that she likes, will she be interested in the new deal that we have? All right, and which customers among our existing customers will be interested in our new deal? Okay, so we will have our own purchase history data over there, which consists of our customers. Okay, so based on that, can we say that some of the customers that we have will be interested in the new deal that we want to bring? Okay, so all these are things that we would like to measure using the data that we have, or we like to recommend using the data that we have. All right, now we have a case over here, right? We have a scenario over here which we want to base on to make the recommendation. Okay, so we have this particular user over here, right? And we have transaction history, then we have the user attribute of this person, right? What we want to do is to make a recommendation over here. So imagine you are a marketing data scientist or machine learning engineer in a certain bank, and you need to decide whether a particular existing candidate is a good candidate for a special term deposit that the bank is currently running. Okay, so the bank has issued some new kind of special term deposit. Okay, and we want to see which of the people that are going to qualify for this kind of special deposit. Okay, so you as a data scientist or machine learning engineer, you need to make that recommendation, that which of the existing customers are you going to recommend for them to qualify for this new term deposit. Okay, now if the client is a good candidate, then you recommend him for a bank representative to reach out and then make him the offer, right? But if according to your recommendation, right, the client is not a good candidate for the special term offer, then you're not going to recommend. Okay, so recommendation system need not to be complicated, right? You can also build a simple recommendation system. I wanted to actually show you this one because previously I've shown you some kind of recommendation systems that are more intense, which we are going to use them as we proceed. Okay, but I also wanted to bring in over here that recommendation systems are not that always complicated. All right, you can build a simple recommendation system which can also work very, very effectively, right, for you. All right, and not that always you're going to build something dramatic or something robust like what we did earlier on, right? But you can also build a recommendation system which works perfectly, but as simple as possible. Okay, so here we will use logistic regression to decide whether a customer is a good candidate for the offer and whether the client would accept the offer or not. Okay, and this client is called George with his descriptive history as shown in the above image. Okay, so this is the descriptive history of this client. Okay, he is single, he's divorced man, and he works at the management department. Okay, he has no credit default, and he doesn't have any home loan, right, and he doesn't have any personal loan. So these are the things that this person is, the attribute of this person. So we want to compare this data of the person to the history, transaction history, and also the user attribute data that we have. Okay, he is single, he's divorced man, he works at the management department, he doesn't have any credit default, he doesn't have any home loan, and he doesn't have any personal loans. Okay, so we want to base on this one and then make the recommendation. All right, so let's see how we're going to do this one. Right, so as I said, we're going to use logistic regression here to do this. All right, so here importing the various libraries that we're going to need, right, as we have seen over and over again. Right, the data set that we're going to use is a bank data set, right? It's just named as bank full w dummy vowels something something something, right? But it's a bank data set. All right, so let me just load it so that you see. I've also loaded it at the resource session, so you'll see this name over there, so you can just download it and then you work alongside over here. Right, so this is credit history. Right, I mean if you go up here, we have transaction history, right, and then use some user attribute over there which has been combined together as the bank full history for us. Okay, so the age of the clients, the job, the marital status, the education default, balance, housing loan, contact day, some others which are not even showing here, job unknown, job retired, job services, jobs self-employed, job employed, job made, job student, married, single, divorced, and so on and so forth. Okay, so these are the data points that we have in our data set that we want to use to do the recommendation. Okay, so here I'm going to check the info, right, and you can see that we have 211. You can see that we have a lot of data set records in there, right, and then which the entries from 0 to 45,210, right, and then we have 37 columns, right. So this is pretty much a huge data set, right. If you see the columns and their types, right, most of them are integer, as you can see over here, right. Most of them are integer, right, and then some few of them are objects over there, right. Some few of them are object over there, right. Now in this scenario, I'm not going to do any extensive data pre-processing since we've done that over and over again, and we know how to do things. When it comes to data pre-processing, we know how have our way around them, right. What I'm going to do is that some of them are objects, so I cannot feed this to machine learning model. I can either convert them to one hot encoding or maybe do dummy encoding and all those things. Okay, what I'm going to do is to use label encoder to convert everything to numericals. Okay, just like this, so that I'll be able to feed it to a machine learning algorithm. All right, so I've actually done that, so this one is not necessary anymore. What I'm going to do is that I'm going to select some of the data points. Okay, so I'm going to select all the rows, right, and then the columns I'm going to select from housing loan all the way to the last one, which is divorce. Okay, so if I show you the columns that we have, right, so let me actually show you the columns that we have in our data set. So I'm going to do .columns over here, right. So we have pretty much a lot of columns over there, right. So what I'm going to do, let me even show it from here. I'm going to select from this one, right, from 18, and that is housing loan, right. housing loan all the way to divorce, which are all integers. Okay, that's what I'm going to do. All right, that's what I'm going to do. I'm going to select it from housing loan to the last one, right? I mean, there's nothing wrong doing that, right? Because I've even converted everything to one hot encoding over here, so you can use it, right? But the columns are too much, right, for me to run it as I am recording the video. So I mean, in your own time, you can just include all of them, right, and then do it. I just included only 19 of them over there, right, starting from this I mean, housing loan all the way to divorce. Okay, so that's basically what I'm doing over here, right? And then I store it in a new variable called new underscore bank full. Okay, so let me run that one. Great. So if I show you what I have in that bank, new bank full, right? Okay, now you can see that from house loan all the way to divorce. Okay, all the way to divorce. So that's basically what I want to do. So you can see that now I have only 19 columns over there, right? So now I'm going to do my independent and dependent slicing over here, right? So the X, what I've selected over here is going to be my X, all right, and then my Y is going to be Y, right? In the column, in the original data set that we have a column called Y. Okay, so if I show you what is inside Y, it's just let me go all the way here. Right now, let me show you what is inside Y. Right, so in bank full, let me show you what is inside this Y. Okay. All right, so it's zeros and one. All right, where zero means the person is not going to qualify for the for the new offer, right? And then one means the person is going to qualify for the offer. So if we come up with zero, then we're going to recommend that the person should be contacted and or given the offer. Okay, but if we come up with one, then it means that we are not going to recommend that person for the offer. All right, so that's what basically we are doing over here, right? Okay, so now we're going to use this logistic regression to do it, right, to build the machine learning algorithm over here, right? And that is what we're going to use based on to make the recommendation. So this is what earlier on I showed you over there, right? This is the characteristics of the user, right? I showed you over here. This is the same thing that I'm bringing down here. All right, this is the same thing that we are going to base on to do the recommendation. Okay, so over here the person is single. Okay, the person is a single. So if you go into the our data set, right, remember I selected all the way from house loan to divorce. Okay, if we go up, right, if we go up, I selected all the way from house loan to divorce. Okay, so now I'm going to compare this with the data of this customer with the data that we have. Okay, and then we base on that to make that to make the recommendation. Okay, so let me get rid of this. The person is single, so when the person is single, that will become one over there, right? That will become one over there, right? Which means the person ticks that box. The person is divorced. Okay, so the divorce will tick. Okay, and then he works at the management department. Okay, so at the management department, let's see, you see that we have one over there, right? And it's not in credit default. Okay, it's not in credit default, so you see that we have zero over there because the person is not in credit default, so that is zero. All right, if the person is in credit default, then it's gonna be one. All right, and what else? The person does not have home loan, so home loan 2 is gonna be 0. So let's see, did I select home loan over there, right? Personal loan is here, right? So the person does not have any personal loan, right? So that is also gonna be 0 over here. All right, and then house loan, right? House loan is the same thing as home loan over there, right? So that is also gonna be 0. The rest are also going to be 0 because the person is not having any of them. Right, so that's why you see all of what we have over there, right? So now based on the data that we have, we are comparing that with the user that has come, and then make sure that we do the recommendation right. Okay, so if we extract all the values that we have, right, we're going to have we're going to have 0000001, right? That's what I'm writing here, 0000001, right? And then 000000000, and then 11 at the last. Okay, that's what I'm extracting over here. So now this becomes the feature of the new customer. and then we need to now depend on this feature of the new customer, okay, and then compare this feature of the new customer with the data that we have, okay, and to see if we will be able to recommend this new customer for the special offer or not, okay. So that is the data that I've put right there. I mean the customer data, right? That's what I've put over here, right? And I'm just reshaping it. I'm using np.array to reshape it to to the proper size so that we can feed it to the machine learning algorithm that we built, okay. So now we are going to make the prediction. I'm storing everything in new user, and then I'm feeding the new user to our algorithm to make the prediction, okay. So if we predict 1, we are going to recommend the person for the loan, if we for the special offer. But if we predict 0, we are going to say that we are not going to recommend the person, okay. We are not going to recommend the person for the special offer. So let's see what we are going to come up with, okay. So you see that we have 0 over there, right? So based on this feature, the person is not likely to accept the offer, right? And the person does not even qualify for the offer in the first place. So we will not recommend this person, okay? We will not recommend this person. It's also possible that if you use different customers feature, the person is going to qualify, okay, or not qualify, right? So it's either of the two ways, right? So recommendation system can be as simple as this, right? Not that it's always going to be as complicated as we were doing earlier on, right? You can also build a simple recommendation system like that to make recommendations, okay. All right, now we're going to see how we evaluate the recommender systems in the next tutorial. All right.